Thank you, Terry. Thank you to all of you for being here, and thank you for my invitation. I really appreciate it. So today I'm going to talk about a theory of justice in non-human primates, which is the title that I was given and is challenging both because of its expansiveness and the fact that we really don't know very much yet. The first data that really came out on this question is only about 10 years old, and actually quite a lot has come out in the last decade, but it's still a very new field. So I'm going to talk to you today about what we do know, and then at the end sort of make some suggestions for where we'll need to go in the future. So the best place to start is with what we know about people, and that is that people value justice. So people care very much about what their outcomes are as compared to someone else's. And this is particularly true in situations where individuals are in some way connected. So for instance, if the person down the hall from you who carries a lighter teaching load and does a crappy job teaching their classes gets paid more than you probably care about that quite a lot. However, if they happen to win the lottery, it might not bother you as much because that's a very different sort of thing. That was chance or circumstance. But it's not that they're being paid more for doing either the same as you or worse than you. And the question is whether or not this is something that is general across the humans or whether it is the result of some sort of modern Western cultural belief. And one of the easiest ways to address this is to look at other species. So you can look at what other species do, particularly the non-human primates, primarily because, of course, I study non-human primates, and see whether or not they show behaviors that might be indicative of justice in these species as well. So this was first proposed by Frans de Waal, who in a paper back in the early 90s argued that the sense of social regularity that was seen in chimpanzees told you something about their sense of justice. So this whole idea of social regularity and social systems has come up quite a lot in the last 2 days, and I think it's also very relevant here. I take a very phylogenetic approach, so I'm interested not just in one species, but is looking at a number of different non-human primates. I'm going to focus today on work in the great apes and in the New World monkeys. So this is a capuchin monkey, which is one species I'll talk quite a lot about, because I'm interested in trying to get as many species as possible that are closely related to try and look at what might be some of the underlying similarities in social behavior, in ecology, and in other environmental conditions that may have led to some of these behaviors. And I will say that I also don't necessarily think that this means that this is a homology. In fact, I don't. We see different behaviors across the primates. So despite the fact that they were looking at the same taxon, we still see some convergence and divergence, and I think that that's really very informative. So what does justice look like in non-human primates? I'm assuming you've never seen a monkey or a chimpanzee walking down the street carrying a banner that says Occupy Wall Street. So obviously they've got a very different instantiation of it. And I emphasize that they don't necessarily have the same instantiation as us or the same motives. What I'm going to talk about today are primarily studies where we're looking at behavioral outcomes. So we don't know what their underlying motives are. We know what their outcomes were. And I'm interested in comparing those outcomes to the outcomes that we see in humans. So obviously we aren't going to see the same sorts of things, but we can start to look at some of what we might consider to be the critical features. And I think that these roughly break down into two categories. So in order to have a real sense of justice, first, obviously, you care if you get less than someone else. So you care if you get paid less than another. But we also think that it's important for a sense of justice to care about when you get more or when others get treated badly. So there really are two sides to this coin, and it's not enough just to have the one of them. So the first can be instantiated as responses to inequity, and that's what we have quite a lot of data on that I'll talk to you about today. So how non-human primates respond when they get treated badly. This is an alpha female named Emily, and the alpha male came up and tried to take away her yummy frozen fruit treat here, and you can see that she's recruited Punch, who is the beta male, to come and help her out. So she was clearly reacting to this perceived violation. She had the fruit, somebody else tried to take it. The other side of this is what we might consider prosocial behavior. It's been called prosocial behavior, altruism, lots of different things, but these are behaviors that benefit another individual. So how do you respond when you have the opportunity to help someone? How do you respond when you get more than someone? There's actually quite a growing literature on this, much of which I've been involved with. And I made the decision I'm not going to talk about it today because there's no way I could do justice to both sets of research in 40 minutes. So it's in my paper, but I'm mostly going to skim over it. I really actually made a good decision given the talks we've had earlier today from Pat Scherchlin and Robert Seyfarth and so forth. You know that these guys show prosocial behavior. I probably don't have to convince you of that. So we'll leave it at that for now. Now, if we're interested in how the primates respond as compared to humans, one thing that's very important is actually comparing the primates to humans. So you can use the same sorts of procedures and see if the humans and the non-human primates respond in the same ways. Of course, even if you're using an absolutely identical procedure, you can't guarantee that they actually perceive the procedure the same. There may be differences in the way they perceive what's going on, but that at least gets you as close as you can. And this was made very clear in an early study looking at the ultimatum game. I'll get into the details of it in a minute in case anyone doesn't know it. That was done by Keith Jensen and colleagues that looked at how chimpanzees responded to an ultimatum game. And they found, in short, that chimpanzees showed very different behavior from humans. They were what they called rational maximizers. They were just interested in getting whatever they could. But then this study was replicated with an analogous procedure by Alan Silverberg's group and found that, lo and behold, using the same procedure, humans actually were also rational maximizers. They didn't show the behavior that we've come to expect in ultimatum games. So in fact, the take-home message is they might have responded very similarly in this procedure. They just didn't give us the response we expected. So the ultimatum game is a game that's related to fairness and justice and so forth, in that two individuals have to bargain, a very simplistic bargain, to split a pot of money. So one individual, the proposer, has to split a pot of money between themselves and a responder. The responder either accepts and the rewards are handed out as the proposer divided them, or rejects and nobody gets anything. So nobody can quite agree on exactly what we're measuring. Is it punishment? Is it justice or fairness or whatnot? But importantly, human responders routinely reject offers of less than about 20%, 20 to 30%, which means that they get nothing. And if you're a completely maximizing human who's only interested in how much you make, this doesn't make any sense because it means you're turning down money. But what's important is you're getting relatively quite a lot less than the proposer. And the other side of the story is that across most societies, and in particular modern Western societies, proposers typically offer about 40% of the pot. So they make an offer that's almost an even split, which means they too are giving up quite a lot of their money. So the question is, what would chimpanzees do in a game like this? Now, it's hard to do a game where you explain that to chimpanzees since they don't speak English or any other language. So we designed a limited form ultimatum game, which is based on the games that are typically used with young children who also may have trouble conceiving of a game like this. So the proposer is just given a choice. Do you want a 5-1 split of 6 rewards, or do you want a 3-3 split of 6 rewards? And then the responder has to make their choice. So in order to do this, we paired 2 chimpanzees, and the rewards were always displayed in front of them. And we trained the proposer that they had to choose one of 2 tokens. There were actually multiple tokens presented, so we could avoid side biases and things like that. They had to choose one of 2 tokens, one of which was worth a 5-1 split of the rewards, one of which was worth a 3-3 split of the rewards. Prior to being tested, they had to pass a number of control tests to make sure that they actually had the requisite ability to understand this. So they had to go through a number of preference tests where they had to show that they preferred 5 rewards to 1 reward, 5 rewards to 3 rewards, which is probably the most difficult for them, and 3 rewards to 1 reward. So we know that they actually care about the differences in the value. We then trained the proposer to pass a token under the mesh or through the mesh to a partner who could then return it to the experimenter. So for the test, what we did was compare the proposer's behavior in what we called a preference test that's roughly similar to a dictator game, where they were simply shown the 2 tokens, or given the option of the tokens. They could choose whichever one they wanted. They passed it back to the experimenter, who then walked up to the rewards and would physically divide them, either move 3 one way and 3 the other, or 1 one way and 5 the other, and then would hand the rewards to the responder first and then to the proposer. So the proposer always saw what the responder got. We compared the proposer's choices in that condition to an ultimatum game condition, which was identical, except the proposer had to pass the token they chose over to the responder, who then passed it to the experimenter. So in this way, we could see if the proposer's behavior changed. We were also interested in the responder, but similarly to the previous game, with ultimatum game that was done with chimpanzees, responders never refused, which might not be all that surprising given that refusing meant not returning a token to a human experimenter. They're a little bit overtrained on behaviors like that, so it's really not that surprising that they wouldn't do that. But what we did see was a big change in the proposer's behavior. So in this preference test, they overwhelmingly preferred the 5-1 option. So 90% of the time they chose the token that gave them 5 rewards and their partner 1. But when we switched to the ultimatum game condition, 70% of the time they chose the 3-3 option. So the proposer changed their behavior even though the responders never refused. But they nonetheless switched their behavior, and this was in a very small number of trials too. We didn't want to run very many trials because we didn't want to train them to do this. So this is really interesting. They're never refusing, but we did see some communication. Not enough to statistically analyze, unfortunately, so all of this is anecdotal. But only in the ultimatum game procedure did we see a few instances where chimpanzees would scream at the chimpanzee responders would scream at the proposers, they would bang on the mesh, they would do other sorts of things that in a chimpanzee indicates that they aren't particularly happy. So it may be that they were communicating these behaviors to the proposer. And of course, why would you, this is much cheaper than refusing. It's very efficient when you're working with known individuals, and these guys were all tested with chimpanzees within their large social group. So these were chimps that they knew and interacted with on a regular basis. We also tested this on children. So we took children from daycares and we paired them with another child from their daycare class. So similar to the chimpanzees, they had an existing relationship. This wasn't anonymous. And children showed the same switch in their behavior. So they also never refused, incidentally. And they changed their behavior between the preference version and the ultimatum game version. And we also saw some communication, although it was more along the lines of, that's not fair, or why did he get more than me? So we think that this shows that at least in outcome, we've got some similar underlying behaviors between humans and chimpanzees, which indicate that really we should be looking at these questions more closely. Now, a game that's closely related to the ultimatum game is one called the impunity game, which is rarely used in human studies. The impunity game is identical to the ultimatum game, except that if the responder rejects, they don't get anything, but their partner still gets something. And so this is rarely studied because it's believed that no rational human would ever reject. After all, you're getting absolutely less and relatively even less by rejecting than by accepting. But Toshio Yamagishi's group has shown that actually humans do reject quite a lot in the impunity game. So he gave students impunity games and ultimatum games and found that for a given distribution of rewards, refusals were about half in the impunity game what they were in the ultimatum game, but still quite high, 20 or 30%. So people do tend to refuse. Toshio argues that this is a way of sending information, sending signals about your intent, and even in situations where it was double-blind, maybe even sort of sending information to yourself about what kind of person you are. So this game is rather difficult to do in total with lots of different primate species like I'm interested in, because as you saw from the ultimatum game, there's quite a lot that goes into training them to make sure that they really understand the proposer's role. You don't want the responder to be making a decision based on just, well, hey, here's a distribution. So for lots of the work that's following, we just looked at this part of it. And we looked at how the responder responds to a given reward distribution after seeing a proposer after seeing another individual from their social group get a different distribution. So the proposer, there is no proposer or responder, they have nothing to do with it, but we're interested in this same sort of reward distribution. How do you respond when you get less than another individual, and do you ever refuse? Similarly to the impunity game, it doesn't make a whole lot of sense to refuse because you get relatively and absolutely less, but we were curious as to what they do. So we've run an enormous number of conditions on an enormous number of species, but these are the 4 conditions that I'll talk about the most. So first is simply an equity condition. How do you respond when you do a task and get a cucumber or a lower value reward after watching a partner do a task and also get the same lower value reward? Just to tell you how these rewards are picked, we pick them prior to testing. So every individual who's going to be tested is given on 2 consecutive days a dichotomous choice between the rewards. And they have to prefer one reward over the other a minimum of 80% of the time on both days, not in total. And then on the 3rd day, they have to be willing to eat at least 10 consecutive pieces of the lower value reward. Because if they don't like the lower value reward, then obviously that affects the result as well. The vast majority of species by coincidence it's cucumber and grape. So rather than saying less preferred reward and more preferred reward, I'm going to say cucumber and grape. But it does vary in a couple of species. So what we're interested in is the subject's behavior when they get this cucumber as compared to their behavior when they first watch a partner get a grape or a better reward, and then they get a cucumber. So do you respond differently to exactly the same situation depending on what happened to your partner? Of course, it could be that you're responding based on what happened to your partner, or it could be that you're responding just because you see a grape out there and your attention's been drawn to it because it's been given to a partner and now you want it. So we also have a control condition that we call the contrast effect condition, or the equity plus grape condition. So for this one, we wave the grape in front of the subject. After they gesture for it, the grape goes back into the bucket, and then they have to trade and they get the cucumber. Which is actually quite mean. But we do the same thing for both the partner and the subject. So in this case, your attention's being drawn to the grape, you're getting a cucumber, but exactly the same thing is happening to your partner. So there's no inequity there. I'll also talk a little bit later about the role of this task. So for most of these, we make them exchange. We've also done what we call a gift reward condition, where we simply hand out the rewards. So these are chimpanzees, and these are data tapes I wanted to show you briefly. So the first one is an inequity condition. Find my cursor, there we go. So this is, oh, can you turn the volume off? I'm going to talk over it. So this is Magnum. He just exchanged and he got a grape. And this is Hillary Schiff, who is doing her honors thesis on this. She's actually finishing up her PhD now at NYU. She's trying to get Sean to come over to do his trade. So Sean has 30 seconds to come over, and he does not have to come to any particular location in the room. We didn't want them to have to come to a particular spot because differences in social relationships could make it challenging for a subordinate individual to come. So we'll go to where they are. They have every chance to trade this. So Sean's over there now. Now he's heading towards the back. If you look, Sean is piloerect, so he is definitely stressed out. So eventually he's going to come over, and this is cut off because this is a data tape, so it's just the way the camera was. So he eventually returns the token, and then you may be able to hear it over. That's Sean when she offers him the cucumber. So Sean's not enthusiastic about the cucumber. Meanwhile, Magnum's left, but when she comes down, Magnum comes right back over, and he's going to exchange and obviously take the grape. Now, Sean's come back over this time, and he has to take the token all the way inside for it to count. So the first time he takes it, he doesn't get it all the way in, so she makes him take it back. And he returns it, and then he just walks off. So he doesn't even stick around to wait for the cucumber. So we aren't measuring subjective reactions. We're simply measuring how they respond. Do they refuse or not? But you can see that there are obvious behavioral reactions in there, too. We're actually trying to get into some of these now. And this is the equity plus grape condition. These are two other males who are also at Yerkes. So this is Amos and this is Phineas. Whoops, that wasn't what I meant to do. There we go. So she holds up the grape. He gestures for it with his fingers there. He does the exchange, and then he's going to get a cucumber. So despite the fact that the grapes are being made just as obvious, they're sitting here calmly. They're taking their cucumbers. They're eating them. You can see he's eating it there. Here comes Phineas's turn. He sticks his fingers out here, indicating that he saw the grape. But he does the exchange, and he's going to take his cucumber. So this shows you the difference in the behavior. I sometimes think the video clips are more illustrative than the graphs, because they show you how they respond differently. We first tested this at Yerkes National Primate Center. We used chimpanzees from two different social groups. Both of these social groups are multi-male, multi-female. They both had more than 20 individuals in the social group. And we were able to test males and females from both. The big difference between these social groups was that this one had been together for approximately 30 years when the test was done. So all but one of the individuals in the study was born into that social group. And the exceptional individual was the alpha female. She'd been about 3 when the group was formed. So she'd been there when everyone else was born. This group had been put together when the individuals were all adults. They had been together for 6 years, so they knew each other quite well, but they hadn't grown up together. So this is a very atypical chimpanzee situation. We were also able to test 2 pair-house pairs of individuals. Most of the chimpanzees at Yerkes are in large social groups, but occasionally if pairs have to be pulled out for some reason. They also had indoor-outdoor access to exactly the same enrichment, but they are living in a pair-house situation, which is extremely atypical for chimpanzees. So we wanted to see if there were differences in behavior between the types of social housing. And what we find is in the short-term group and in the pair-housed group, you see a fairly robust response to inequity, particularly in the pair-housed group. And you also see a response to this equity plus grape condition. So they do care when you wave a grape in their face and don't give them anything, but they, particularly in the pair house situation, they care more when you give it to their partner. What's particularly interesting is the long-term group. So there are 10 individuals represented in these bars, and these are standard error bars. And you can see there's almost no variation. These guys almost never refused in any situation. And so what's really, I think, an interesting take-home message here is the huge variation you're getting between these atypical social arrangements and this much more typical social arrangement. Now, obviously, that's after the fact hypothesizing. They're different. They'd been cows together for different periods of time. There may have been other differences. There were certainly different individuals. But this tells us, importantly, that there is a lot of contextual variation in their responses. And that's something we're looking into further now. The next stage was to test this again. We tested it at MD Anderson Cancer Center. They have a facility out in Bastrop, Texas. More groups, all multi-male, multi-female groups living in big outdoor enclosures. We were able to test 16 chimpanzees here. And the important thing was all the groups that we tested, the chimpanzees had been housed together since the late 70s. So we didn't have this timing confound. And to tell you the first part of the story, we didn't find a difference in reaction between social groups. But what we did find was a sex difference, which we did not see at Yerkes. So the males are responding much more strongly to inequity than to equity or to this equity plus grape condition. They actually respond the least often to this equity plus grape condition. The females, on the other hand, are responding the most strongly to contrast effects and are not responding to inequity. There's not a significant difference between these two bars. And this is really interesting because all the females, with the exception of one female who never refused a single reward, showed this pattern of behavior, and all the males showed this pattern of behavior. Yet at Yerkes, not a single one of the females showed this pattern of behavior. So the question is, what's going on here? We get some individuals responding in some cases, but not others. There was another study done by Juliana Brauer and her colleagues at the Max Planck Institute in Leipzig, and they found that none of their 6 chimpanzees refused. But again, there seems to be more going on. What we're trying to do right now is look in 4 social groups where we can test everybody with everybody else, and then try and tease apart other factors that might be going on here. So we are working with Sam Gosling. We have personality assessments on these chimpanzees. We've got information on who they're grooming and who they're spending time with based on our weekly observations of every group. So we can go back and look at things like relationships, using the CSI measure that Robert Seyfarth talked about yesterday. We can look at their personalities. We can look at things like dominance because we now have a decent sample size of alpha males and alpha females and so forth, and try and figure out what's the critical factor underlying this variation. I should also point out that I'd really like to know how much variation there is in humans. So in most human studies, the data are clumped. And in fact, in an anonymous double-blind study, there's no way to go back and find out whether the males were responding differently than the females. But I think it'd be really interesting to see whether this variation is specific to the chimpanzees or whether we also see it in other species. I also, as one of the other things that we've been looking into, we've been interested in the factors surrounding the test. So in all the tests I talked about previously, you either got inequity all the time or inequity none of the time. So we went back and looked at how they responded if you only gave them inequitable rewards a percentage of the time. So either 25% of the time, if you were the unlucky chimp, you got the less good reward, or 50% of the time, if you were the unlucky chimp, you got the less good reward. But the rest of the time, you continued to get the same better reward as your partner. And what we find is that they don't respond to inequity when they only get the less good reward 25% of the time. So we had what we called a yoked equity condition and an independent equity condition. I'm not going to get into those now because they're not important for this, but they didn't respond differently to either of these equity conditions compared to the inequity condition when they only got the less good reward 25% of the time. But they were far more likely to refuse in the inequity condition as compared to both equity conditions when they got the less good reward 50% of the time. So it seems to be that they don't just respond whenever anything doesn't go their way, but that it requires a certain frequency, which I think is important when you consider it from a natural history perspective, because most situations in which these guys might experience inequity, such as in sharing food rewards or even social inequities like grooming and so forth, you wouldn't expect to necessarily get exactly the same reward as your partner every single time. So if your cooperation and sociality are going to work, there has to be some tolerance, some ability to accept inequity sometimes if it means in the long run you have this really nice, strong social relationship, which, as we've seen before, is really important for their long-term well-being. I'm also interested in whether they notice when they get more. So I said I wasn't going to talk about prosocial behavior, but I am going to talk about this briefly. So as one of the components of the test at MD Anderson, we included a high-value equity condition where both individuals traded and got a grape. Obviously, they were perfectly happy to trade in every situation for this. But what we were interested in was the partner's response to their grape when the subject also got a grape, as compared to the partner's response to the grape when their subject got a cucumber. So do you respond differently to your high-value reward if your partner gets something less good than you? And we found that a small but statistically significant effect with the chimpanzees where the males responded more strongly to, or refused their grape more often when their partner got a cucumber than when their partner also got a grape. So they are showing this effect. The females aren't, but the females weren't responding to inequity in the first place, so that's not really surprising. This is the same data set as I showed you previously. We don't know why they're making this response. We did not ever see any sharing. We never saw one of these guys give their grape to their partner who got the cucumber. But nonetheless, the important point is that they're noticing that they got a better reward than their partner. I'd also like to point out that the difference between refusing your grape when your partner gets a cucumber and refusing your cucumber when your partner gets the grape is quite large. So this is how they respond when they get the cucumber. This is how they respond when they get the grape and their partner gets the cucumber. But nonetheless, we are seeing this response. I'm also interested in the role of a task. So in the human literature, it's been proposed that one of the functions of inequity responding is partner choice in cooperative situations. So you pay attention to how much you get as compared to your partner when you're interacting in a cooperative situation. For these guys, think colobus hunt or something along those lines. And if you continually get less than your partner, then it's time to go out and find a new partner. And if you're getting sufficiently less, sampling the environment is likely to lead to a higher outcome or a higher payoff than staying with the partner you're with. And if that's the case, then a task might be important. The situations I'm talking about are not cooperative in the sense that they aren't having to work together, but the task may be critical for sort of tuning into this behavior. And it actually came to our attention because after the initial studies came out on inequity responses in chimpanzees and capuchin monkeys, the studies were repeated numerous times, and a lot of people, rather than including the task, which takes a while to train, simply handed out the rewards to the primate. And there was never any evidence of an inequity response in any species that was tested without a task. And this was even true within the same population of capuchin monkeys. So in our initial study on the capuchin monkeys at Yerkes, they showed a strong response to inequity as compared to equity. Marietta Dindo, who was a graduate student of Franz de Waal, she now works at the Atlanta Zoo, replicated this in a slightly different paradigm where she just handed out rewards, and she never saw any refusals. In fact, if anything, she saw a social facilitation effect. They were more likely to eat the less good reward if their partner got something better. And then another one of Franz's graduate students, Megan Van Wolkenton, repeated this yet a third time on the same group of capuchins, used the same procedure where they had to do a task, and found a response to inequity. So this is certainly interesting. It looks like there's something about the task, but the problem is these studies were spread out both temporally and they had different procedures and different experimenters and so forth, so it's really hard to draw any firm conclusions. So when we were testing the chimpanzees at Bastrop, we added in this gift-reward condition that was properly counterbalanced and within subject design, so we could look at how they responded to getting a cucumber when their partner got a grape, when they were simply handed those food rewards for free, versus when they had to exchange to get them. And we saw a big effect. So again, the males are responding strongly to inequity as compared to equity plus grape. The females are responding strongly to the equity plus grape condition as compared to inequity. Neither one of them are really refusing in the gift reward condition. So they don't seem to pay as much attention to those rewards, or at least they don't seem to react as much to those rewards when they're simply handed out as compared to when they have to do a task. We've since done some more work looking at whether the task matters, and based on one study, it doesn't seem that it does. As long as it's a task of some sort, it seems to trigger the same reaction. So the next question is, what's the function of inequity? In humans, as I said, it's been proposed that this is tied into cooperation, which is a very reasonable assumption in the primates too, but there are also lots of other possibilities. So presumably responding to inequity requires a number of cognitive capacities that might be important. You've got to be able to judge rewards, you've got to be able to compare your rewards to those of another, So it could be something that's related to brain size or to cognitive capacity. It could be something that's tightly linked to sociality. Maybe the larger your social group, the more likely you are to respond negatively to inequity. And the primates are nice for doing these sorts of comparisons because they are fairly variable. We have a couple of nocturnal primates. Either they live in, we even have a couple of nocturnal primates. They live in different sized social groups. They have different sorts of breeding arrangements. So for the last few years, we've been interested in testing as many species as possible using exactly the same procedure to see if we can get differences in response. So what I'm going to do now is talk about all of these. We've thus far tested squirrel monkeys, capuchin monkeys, owl monkeys. We tested common marmosets, and Julie Nyworth has also tested tamarins. And we and a couple of other groups have tested chimpanzees and orangutans. I'm going to present my data because I know that the procedures were absolutely identical across them. The important thing to note is in all of these cases, we tested individuals who were socially housed. We tested them with members of their social group. And we were interested in their responses to these rewards. Now, again, the rewards sometimes differed, but they were always using the same criteria of you had to prefer one over the other 80% of the time. So just running through these, this is always the percent of refusals, and it's always equity, inequity, and equity plus great. The orangutans do not respond to inequity. So we tested 8 orangutans at Zoo Atlanta, and none of them responded to inequity, none of them responded to any of these 3 conditions differentially. We also looked at capuchin monkeys. Capuchin monkeys have now been tested in several different situations. We find that they respond to inequity as compared to both equity and equity plus great in 2 different studies that we've done. There was a study done by Grace Fletcher at University of Georgia that found a similar response, and Ayaka Takamoto has done something that was an analog of this procedure, but also found a similar response, indicating that this is really consistent in capuchins. We also don't see as much individual variation in the capuchins as we do in the chimpanzees. Intriguingly, squirrel monkeys, who are confamilial with chimpanzees and actually sympatric in large parts of their range, show a very different behavior. So male but not female squirrel monkeys respond to the equity plus great condition, but they do not respond to the inequity condition. So they seem to be much more responsive to the contrast effects than they are to inequity. And this is actually interesting because despite similarities in everything from body morphology to ecology, squirrel monkeys are not known in the wild to spend as much time in coalitions and alliances and so forth as the brown capuchins are. So it's possible that we're seeing a difference in social cooperation here. One of the problems is there have been almost no studies on cooperation in squirrel monkeys. Actually, there have been none. There's only been one that's even looked at food sharing. So that's something we're working on right now to see if in these experimental situations, the squirrel monkeys respond to cooperative tasks in the same way as the capuchins. But this is really nice because it shows, and this is a sample, by the way, of 24 squirrel monkeys, so it's a large sample. So this is nice because it shows us that there is this convergence or divergence even within this family group. We also tested squirrel monkeys in 2 different ways. One of the chimpanzee studies that was done by Juliana Brouwer found that chimpanzees didn't respond at all to inequity. And one of the big differences between their study and ours was that in our study, the chimpanzees were sharing an enclosure and typically sitting next to each other, like you saw in the videotapes. But in Juliana's study, based on the way in which her facility was designed, she didn't have a choice but have them sitting across from one another, facing each other across a 1-meter little room where the experiments took place. So the chimps were not together, and they were facing each other rather than next to each other, so you worked with one and then worked with the other. And her chimpanzees didn't respond. So we actually tested this is the group of squirrel monkeys I just showed you the data for, the males. We tested a new group of squirrel monkey males, but we removed the barrier from between them. So the squirrel monkeys were tested with a barrier because squirrel monkeys are frenetic and they steal each other's rewards, so it was practical. But we were interested in what they would do without this barrier. And intriguingly, while they still respond the most strongly to contrast effects, they do show a bit of a response to the inequity condition when they're sharing an enclosure. I suspect this is because they're actually close enough to one another to pay attention to what each other's rewards are. I don't think it's anything more important than that. But it does show that it's really critical to keep in mind the procedural differences and consider how the differences in procedure might be affecting differences in results. We also didn't find any response to inequity in marmosets, and neither did Julie Nyworth and her tamarins, and we didn't find a response to inequity in owl monkeys. And these 3 groups are particularly intriguing because they are interdependent. So these are those unusual mammals who are actually pair bonded. So the calatrichids, the marmosets, and the tamarins are cooperative breeders, so it's not just the parents, but often weaned offspring hang around and help as well. Owl monkeys tend not to have the offspring around, but they're obligately interdependent. Both parents are required to raise the offspring. So these guys are particularly interesting because they're highly cooperative in one sense. They have to work together in order to raise their offspring. And they've been shown to be highly prosocial in lots of other studies. They're very willing to bring food to each other. But we tested all these guys with their mated partner. And then we don't see a response to inequity. So it may be that what we're looking at here is that a cucumber is simply not worth upsetting your mated partner over. This has been a hypothesis in the human literature that the relationship between individuals strongly impacts responses to inequity, and this may be the case in these guys as well. So looking across the species that have been tested, I've highlighted them in green if they respond to inequity and red if they don't. And you can see that it's clearly not a homology in the primates. And it's also not explained by brain size, given that the orangutans are not responding, nor is it explained by sociality. In fact, what it seems to be best explained with, given the subset of data we have right now, is that yes, individuals who cooperate outside with non-kin do seem to be responding most strongly. And the exception is these cooperative breeders and interdependent species here. And I think that really deserves more explanation. I think that this probably ties into Carl van Schaik's and Sarah Blaffer-Hurdy's ideas about the evolution of cooperative breeders, and I'd like to see how relationship equality affects their responses. This would also be interested in humans who are typically tested outside of their pair bond, but it would be great to see humans who are tested in their pair bond and see how their responses varied. They might look a lot like the calatrichids and the owl monkeys. We also are just getting in data on rhesus monkeys, and we've been able to do a developmental study. And it looks like rhesus monkeys are responding to inequity, but intriguingly, contrast effects come online first. So they look like they're responding to contrast effects at about a year of age, but by 2 years of age, they're responding to inequity. So these data are very preliminary, but I think they're very interesting. The last thing I wanted to talk about is cooperation and inequity together. So if inequity is a mechanism by which individuals find good cooperative partners, then one would presume that inequity in a cooperative situation would affect behavior. So with capuchin monkeys, we did a simple bar pull task. These guys have done lots and lots of similar sorts of tasks, and they're very good at it. They understand the contingencies of cooperation. 2 monkeys were, in part of their home enclosure, were given access to this counterweighted tray. The tray was about this wide. Capuchin monkeys are about house cat size, so they were actually quite distant from one another. They could work together to pull in the tray that was counterweighted heavily enough that they could pull it in if they were working together, but no one monkey could pull it in by themselves. And there were always food rewards for both of them. But sometimes they were 2 of the same food reward. Either they both got apple or they both got grape, or sometimes they were different. And if you're wondering why it was apple and grape and not cucumber and grape, it's because in control tests, they declined to pull reliably for cucumber. So again, we only tested individuals who preferred grape over the quantity of apple that we used 80% of the time on 2 consecutive days. And what we were interested in was whether they would pull differentially in this condition where they have to negotiate who's going to get the better reward. So these guys are not constrained. They're free to come and go. We actually tested them in their home enclosure. We locked everybody else in their group into the outside part of their enclosure. So they weren't in a test area, which I think probably encourages individuals to respond just because they're bored or there's something right there. So they could come and go as they wished. And that's not what we found. They pulled equally in all 3 conditions, whether they were unrelated pairs or whether they were mother-offspring pairs. But what we found, and this is just for the unrelated pairs, but it also holds true for mother-offspring pairs, is that in some of the pairs, we call them equitable pairs, both individuals got the grape in the apple-grape condition about half the time. So the dominant took it, I think it was 54% of the time. While in other pairs, the dominant took the grape in the apple-grape condition about 80% of the time, actually a little more than 80% of the time. So if you're in one of these pairs, then you're splitting the grape about equally in the unequal condition. Whereas if you're in this pair, you're always getting the less good reward or always getting the better reward as compared to your partner. And if you look at partner success, if you look at success of these partners across this dimension, you see that the equitable partnerships are almost 3 times as likely to succeed in the cooperative task as the inequitable partnerships. And importantly, it's not just in this condition where they get different rewards. They do the same thing in the grape-grape and the apple-apple condition, we never saw an individual steal a reward. So it wasn't that they were afraid to pull in here because they thought their partner was going to get both grapes. And this is true of these bar pull tests across years of study. They don't steal each other's rewards. So what I think is important here and ties in very nicely with the cooperation hypothesis is that they're not responding to the distribution. They're responding to their partner's behavior. So this is something, we're actually rerunning this study with the squirrel monkeys right now to see how the squirrel monkeys respond. And it's something that deserves more greater look in other species as well. So just to quickly summarize, inequity is a convergent trait in the primates. Individuals which are more cooperative with non-kin seem to be more likely to respond to inequity, with the exception of the interdependent species, which certainly requires more study. Cooperation and inequity certainly interact as well, at least based on this one study. Individuals are also sensitive to their partner's outcome. So thinking back to the ultimatum game and to how they responded when they got the grape but their partner got the cucumber, they are paying attention not only to what they get, but what their partner gets, which I think is a prerequisite for any sort of sense of justice. You've got to be paying attention to both. And I emphasize that that doesn't necessarily mean that they have pro-social or altruistic motivations. It's very self-interested for me to make sure that you get enough rewards that you keep being willing to work. Because if you quit being willing to work, then I don't get anything at all. And so I think we need to be paying more attention as to how some of these behaviors interact with one another. So I think in short, we don't really know how justice has evolved in humans yet, and we certainly don't see the same sort of justice in non-human primates that we see in humans. But we certainly see some of the precursor behaviors here, and I think that this tells us a lot about the evolution of our own sense of justice, and also the context in which our sense of justice may differ. Thank you. Oh, and thank you everybody up here too.